Hey everyone, welcome to this episode, Thinking Like a JavaScript Program. This is a suggested mental model on how to think about JavaScript. Programming languages are limited comparing to human language, right? We cannot express ourselves in programming languages the same as we can express ourselves in a human language. So hopefully it will be easier for you after this lesson to program in JavaScript and understand what your program is doing. So we'll start with variable and primitive values. And when we talk about primitive values, we talk about string, number, boolean, null, undefined, big int, and symbol. Those are the primitive values that we have in JavaScript. Why they're called primitives? I think that after this lesson, it will give you a better understanding on why they're called primitive values. And what I want you to see is I have this code snippet here, which is relatively simple. To the right side, I have two columns. One is the variables column, and the other one is the values or memory column. And this is this mental model that I'm suggesting. This is the way to think about the program. This is not code. This is just a way of thinking about what happening when the code runs. And you will also see a white arrow, and this is a reference or a pointer. Okay, so something is referencing to something. Usually a variable is referencing to a value. We will see how it goes. So we have let A, we're declaring a variable. And when we're doing this, JavaScript is creating a variable in the variables world. And on the next line, we're assigning a value to the variable, right? So we're saying A equals to 1. So JavaScript creates a value in the values world, makes A pointing to this location in the memory. And you can see here to the right side, I'm also outlining the type of the value. So in this case, it's a number. In the third line, we're having the same thing, just in one line. This is how usually we're creating variables and values in programming languages. We have let B equals true. And JavaScript just does the same thing, only with one step. It creates a variable, creates a value, creates a reference from the variable to the value with the type Boolean in this case. On the third line, we have something new. We are creating a variable and we're saying the variable C equals the variable A. And this is what happens. What JavaScript does in the case of primitive value, it takes whatever value A in this case is pointing to, so A is pointing to 1, creates a copy in the memory and then saying C is pointing to number 1. Okay, so even though they have the same values, there are different places in the memory. Now, it's not always right on how it works behind the scenes. I'll be frank, I'm not 100% sure on every JavaScript engine what is the C code behind the scenes that actually allocates memory and referencing those variables to these places in the memory. But it doesn't matter. What matters is what is the mental model that we have in our mind and if it works. And in this case, it works. It helps us understand what's going on. And you will see why it matters. You will see when it's beneficial. Let's go to the fifth line. So what I'm doing, I'm mutating. I'm changing the variable C. I'm saying take variable C, and this plus plus operator is to add one number or to increment C by 1. And what will happen in this case is that JavaScript will take the value of C, but whatever C was referencing to, it was 1, adds 1 to it, and creates a new place in the memory where C is pointing to now. Okay, so now C is pointing to the number 2. And on the last line, we're taking A, which is the variable we declared before, and we added the value to A. We instantiated A with a value. We created a reference for A, and we're now assigning a new value, in this case, string. And string is a primitive value. In low-level languages, sometimes strings are not primitive values, but in the case of JavaScript, it is a primitive value. So in our case, it works the same like any other primitive value. And what happens is that JavaScript creates a new place in the memory and adds this hey string in the memory. And you see we have it in the memory. And now A is referencing to this new place in the memory. It no longer referencing to the number that we assigned on line 2. It's referencing to a new place in the memory, okay? And what we need to take out of it, that when it comes to primitive values, when we assign primitive values, when we change variables that has primitive values, when we assign variables with primitive values to other variables, what happens is the JavaScript creates a copy. And this is what we need to keep in mind. It creates a copy. So when creating a new variable with a primitive value, the variable references to this value in the memory. When a variable with a primitive value is assigned to another variable, the value is copied and assigned to the new variable. It creates a copy of whatever the previous value was referencing to. They are not referencing to the same value in the memory. Let's go back and see. Even though C is equals to A, C is not referencing or not pointing to the same place in the memory. This is a mental model of how to think about what happens in the program. Let's keep with it. Okay, so it creates a copy. And even when we are changing a value, when we changed C, for example, it allocates a new place in the memory and referencing to this new place.